I guess a bit of coughing is always a good start to the stream, especially in these COVID days. But well, anyway, welcome to the stream. So this is the second stream in my sort of little sharing my troubles stream series, where I'm looking at programming or learning how to program Rust and understanding sort of the complexities of this language and its really particularities, right? So the goal of this stream series, or the first part of this stream series, is to write a simple epidemiological model. So what that means is that what I'm trying to achieve is I'm trying to make a simulation in which you basically put lots of people, then you seed some people there that are infected, and then as their disease progresses over a number of days, they infect other people, and the people that are infected either pass away or they recover and then have some level of immunity. So if you simulate a certain number of people, then you get this interesting sort of sigmoid curve, which means that it's an S-shaped kind of curve that the infection spreads very, very quickly until the point where immunity is achieved. Then it spreads slower and slower, and eventually it flattens. Some of the interesting things about the interesting question you can ask yourself in this model is, does every person in that model get infected? And what are the characteristics of this curve as it rises? So it's in many ways it's a very simple programming task to make such a model. It can easily be done, but the idea here is to learn Rust by making a few of these projects, and I have some more projects that I would also like to do if I succeed at this one. In the first stream, we looked at how you could multi-thread such a simulation and share data inside that between threads. And starting, however, to write a simulation, it became clear pretty quickly that the limitations that Rust puts on how you handle memory, at least without using APIs that also comes with Rust to do things like sharing mutable references to objects. And if you just use the standard type of variables that come, like just regular variables, then Rust prevents you from doing certain things that would seem very obvious in other languages. So we ended up on not managing to write the simulation, and the reason for that was that I had sort of a simulation object, and that simulation object, of course, had a multitude of person objects that represents the people that could get sick, but the logic for how you develop your infection and picking out the people that you infected, that was implemented as a method on the person object. And the problem with that is that I guess here's the interesting thing, right? So when you call a method on the simulation, you have to provide a this or a self variable to that method. We'll have a look at this in a moment in a simpler example as well, but you have to provide a self or a this variable, and everyone that works in object-oriented programming, of course, recognizes these objects. And then if you want the person object to pick people to infect from the simulation, then the person object also has to know something about the simulation. So the natural sort of way that I think about this from other languages is that I want to pass a reference to the simulation into the person object, and then the person object will pick something out of the simulation and sort of handle that data. But the reason that doesn't work in Rust is that because the self object has to be mutable, that is, it has to be read and write, then you can only have one of those at the same time. And when you call the person object with a reference to the simulation, you either have to take a mutable or an unmutable reference to the simulation and pass that into the person object. And Rust doesn't allow that. The Rust has a very simple, is it simple? I don't know. It has a set of regulations or rules that make sure that you don't have these safety and data race issues that you have in other languages. And one of those rules says you can only have one mutable copy of your variable at any given time. The variable has to have an owner, and you can, alternatively to having one mutable copy, you can have multiple unmutable references. So you can read as much as you want from an object, but you cannot read while that object is available for writing in other methods. So intuitively this makes sense, but it has implications for how you write your software, right? And then there are ways to come around it, but that means that you have to use an API that provides certain guarantees for how your software will deal with those variables, and also will panic or crash the application out if it comes to an event where its behavior is unsafe. And that's actually kind of cool when I think about it. But it does mean that you have to structure your code in ways that are different from what you would do if you were writing this in a regular object-oriented language. So the thing that we will look at today is I got some great answers, really great answers from Stack Overflow and also from Discord. And there's a Discord called Programmers Hangout that has a Rust language channel, and I asked there. And I also and I want to go through some of those. I want to go through those answers and see if we can change our model to work. Then, if we manage to successfully implement logic that sort of makes sense, then we will move on and make modules out of the simulation and the person, so that it's a bit tidier than what it was at the end of our last stream. I have a feeling there'll be a third part, because I don't think I can go on forever tonight, but we will have a look at it. But first, let's clear out one thing from the first stream, and that is one thing that sort of made me wonder in the previous stream. Oh, by the way, this thing that I mentioned about simulation and the person object, it was a very good title for one of these Stack Overflow posts about this, and it says passing mutable self-reference to method of owned object. And this is a very good, this feels very like the proper way to describe the problem that we had. But let's start with the beginning. In the beginning of the previous, in the beginning of the first stream, I had this thing that made me wonder, because I thought, well, if I'll show the example. So we have one thing here called copy type, and that is the, so we're going to start CLion, which is the IDE I'm using for these things. Like this. Okay, so in the previous stream, I was surprised that if I had an iterator in this case, okay, so what, basically here's the thing. Never mind this structure, we will have a look at that later. So here's a very simple program for us. So we loop through the numbers 0 to 10, and we keep the n. So n will have that number. This is a syntax here. That means that n will get 0, 1, 2, 3, and so on to 10. And then we spawn a thread, and we print the current number. And when we do that, we use move to move n into this enclosure. And the Rust borrow checker concept basically means that since you can only have one owner, it sort of seemed intuitive that when you use move here, then you cannot reuse n here. But by the way, this just sleeps the thread for 1 millisecond, so that these threads that are spawned here are allowed to output. Okay, so if you run this, however, this runs just fine, right? You can remove this reference, get it a bit cleaner. So you can see that the threads start printing out before all the threads are spawned, and then we go down here and we get this mess, right? So I thought when I saw this, and actually I knew the answer, but then I saw this, I was surprised that we could continue to use the n afterwards here, because to me it seemed that would mean that we were using a value that was already borrowed. But let's have a look at an example where actually that logic is true. The reason we don't have a problem here is that we're not actually moving n into this closure. What we're doing is we're copying it into the closure, because the integer 32, it's a copy type. It means that it's copied on when it's needed. But let's say that instead of but let's now pass a struct which is different, right? It's not automatically a copy type. The basic types of the language are copy types, but but structs that you generate will not be. Apparently tuples consisting of copy types only will be copy types by default. But we'll show how to get around this any second now. Okay, so we're going to create another struct called thread info. Let's say you want to keep some information about the threads that you are spawning. Let's get rid of this. In this particular case, what I am doing is that I am creating a new thread info and I'm passing it the n, right? And again, n is a copy type, so we're now going to have both n and the thread info. So let's now say that we want to take this thread info and we want to, it's called thread info, and then we want to print a number. So we're doing exactly the same thing as we did earlier. We're looping through the IDs or the numbers of these threads that we have spawned. But in this case, what we want to do is we've now wrapped our n in this thread info, and we're gonna let this go first. So the question now, does this work? Every time we go through the iteration, we create a new thread info with the number, and then we print that. So let's try that. Yeah, no problem. That worked just fine. So here's a question: what happens if we try to use thread info afterwards? And then we get the borrow of moved value. So what happens here is that we have moved this time. This is not a copy type because we have created that. So we are now moving that into the thread. No, we're not move. So when we move it, it means that now it is moved. We cannot use it here. In fact, one very, very simple solution to that is to use this macro thing, or this, I'm not actually sure what you call this. But this tag thing here allows you to add copy or automatically add the copy type to this. So what happens when we run this now is that it works again. Now we have, so in this way we can very, very easily add the copy type to this object. I'm going to try one thing now. So what we did now is, of course, the thread info in here is no longer the same as the thread info outside here, which is of course an issue, right? So another thing we could do if we wanted to have multiple references to the same thread info, we could create ref cells, or we could create arcs or mutexes and so on, and then we could do the same. We could do the same kind of thing. But this demonstrates the concept of the thread info. One thing I'm curious about is how easy it is to implement. Okay, so the copy trait, I think it just has one function that the type has to have. Let's try to do. Is this implement copy for thread info? Just try this. Okay, the trait clone is not. Yep, so we have to, okay, clone. So we have to do copy and then clone. Then I think we have to put a method here that will take what we had and is implement members. Yeah, do we have to do both? Yeah, I guess we have to. Okay, so to implement this, we have to clone, which makes a copy of self. So the simplest way to do this would be just returning. This will be immutable. So okay, so let's just try this. We can now create a new thread info, and then we will just take the self dot. This will be number is self dot number. Can we do exactly the same thing down here? Nope. What is that? Do we have to implement? We don't have to implement that. Let's try that. Because now we have implemented the copy type. Just to be curious, let's try and print. Let's try to print. Maybe let's just try to print here clone. And when we do that, let's also add the number that we cloned, so we can do self.number. So, okay, and this is actually really interesting. This does not print anything. Does that mean that it doesn't get cloned? Does it mean... Actually, let's wait, let's wait 100 milliseconds here. Oh, we don't get the clone thing here. Okay, so this function is obviously not running, even though we are doing that. Does this thing have anything we want to know? This surprises me a little bit. I actually thought that this code, this clone code here, would run every time we made a copy of it here. So then I'm actually not exactly sure in what situation this is used. Might also be that this is simply a mark and that it creates a shallow copy just automatically in memory. Anyway, the point of this demonstration is simply to show that the reason why I was wondering about that last time is because of course, and the reason we could use the iterator after we have passed it into the thread, of course, that the iterator was a copy type. So that explains that part of the previous stream and the surprise that we had there. Okay, but let's get back to the idea of passing self into a method on a member of self, and why that becomes a problem. Let's try and see if we can resolve it. Let's first have a look at our epidemiological model as we left it last time. Then we will illustrate with a simpler example the problem that we had. So we can open recent and we're going to do model. Let's have a look at the model that we created last time. This is probably a little bit broken now because I just left it in this state. Okay, so we have a main function. Okay, let's see. So far we only have one file, which is main, and we will expand this into multiple files today to make it cleaner. We have a main function that actually runs the simulation. So what it does is that it creates a new simulation with 10,000 people. It says that the reproductive rate or reproductive number of the infection will be over the pathogen will be 3. And then it loops through 10 people that it will infect. It randomly picks an index, or it randomly picks a person from the simulation, and by that it means that it picks the index of that person. Then it gets the person from the simulation. It runs the infect method on the person. So we changed something here in this method, and that's why we get this error now. We just state to the console that we infected this person, and then we actually then we should here, as we develop this model, execute the model, which means we will run through a certain number of days, for instance 300 days, to see how the numbers in the model develop. For each day we'll record how many people are infected, sick, recovered, or undead, and then we will catch those numbers and plot it out in LibreOffice afterwards. But let's get back to it here. So let's look at the data structures that we have defined. So an ID in the model is simply a usize, which this is the type, this is the size that is used in vectors in Rust, so that you can see. The reason we have this is that the ID of every person in the simulation is the index in the array of people, because that's a simple structure that's easy to grab. It's easy to recover the person, and it will be very, very fast. The drawback of this is, of course, if you split the array into multiple chunks and process them separately, then the ID is no longer valid. If you pop one out at the front, if you slice one out in the front or in the middle, then the IDs are no longer valid. So, of course, this does have certain implications or certain problems to it. We have defined the state of the individual as susceptible to the infection, as infected, as recovered from the infection, or dead. We have identified, we have created a enumeration here called sick day, and that means that when a person gets infected, they are sick for 14 days with this, and those 14 days are represented as these sick day enums. And each day that the person is sick, you can either infect nobody, you can infect someone. So this is a simplification to make this structure very, very simple for our testing purposes. You can only infect one person per day in this particular limitation. Simulation carries a little bit of data. It carries the people, a vector of people, and the simulation itself we have implemented here so far, and that's pretty simple. It populates the simulation with people in the beginning. We have a function to randomly pick an index from the simulation, so that equates to just picking a person. We also have the person object, and the person has an ID. It has a state, and the state is one of these states that we saw here. So either this person is susceptible, infected, recovered, or dead. And then we have a method on person that says infect. So here's our problem. This method that says infect will create it will create an array. It should be for so what it creates an array of sick days. And that becomes the course of the disease for that person. So if you look at person, they have a course vector, which it's a vector of sick days. So again, each sick day you can either infect someone or not. So here's the problem. When you are creating a function or a method on person to infect, then you need to know something about the simulation, because it's not obvious to the person object how many people are in the simulation, and it doesn't have access to the method that is to pick a person. So the problem is that we cannot pass the simulation into infect, and I will show you now an example for why this is the case. And to do that, I will use a simplified version of this code to illustrate this, and so it's a little bit less complex. Okay, this is actually definitely not the right one. I thought. Okay, let's actually just recreate that one. It is very, very simple. Or actually, let's even better. Let's look at my original post on Reddit, which has a simplified version of this code. Can in fact copy this and create it in Rust again. So we are going to actually RMF this bank account. We don't need it anymore. And then we're going to cargo new, and we're going to call it bank account. Okay, so in this simplified version of the problem, we will we have a very okay. So here's the setup. Okay, so we have a bank, and the bank has a number of accounts. The bank, with the bank, if you have the bank, you can deposit or have access to the bank. You can deposit money at a specific account number, and you will deposit an amount. Actually, we're going to rename this to amount. You deposit a certain amount of money in that. So what the bank has to do is it has to look up the account. So it will simply get a mutable copy of the account given the index. So it says self accounts get mutable, which means that it gets a mutable version of the reference. So it borrows mutably from the vector. That's actually what it does. It borrows mutably from the vector of accounts the account. This works just fine. So what you could normally think that you would want to do here is that once you have the account and you have it mutable, you could simply say balance plus equals amount. So this is in many ways, this is very simple, right? And in many situations, this is enough. But what if it's a little bit more convoluted? Let's say that you have multiple types of bank accounts, or maybe simply bank accounts need to calculate like a score. For instance, maybe the bank account wants to know wants to calculate the interest rate based on how much money there is in this account relative to all the other accounts in the bank. So let's say that for some reason your account needs, we can actually, when you deposit money into the account, then then that method would need to know something about the other accounts in the bank. If you think in an object-oriented way, you would pass the bank into the account method. So this is the deposit method on account. So the self balance in this case, actually we will change this also to amount. The balance of this should be pretty simple, right? It basically means that each account has a balance, and I've said mean deviation here. Let's say that this is some kind of score that would be calculated by the account based on its, say, how much money there is in that account relative to all the other accounts that the bank has. So in like Python and C# and C++ and so on, it would not be a problem to pass there a reference, in this case a pointer, or in this case to borrow a copy of the bank, or borrow the bank variable to the account. The problem is that when we are doing deposit on bank, when we're calling the method deposit on the bank, then the deposit has a mutable copy of self. And when you have, this is the basic borrowing rules of Rust. When you have a mutable copy, you cannot make any mutable copy. You cannot borrow again an immutable copy as long as this mutable copy, mutable borrow exists. So this doesn't work. We can try and run it. Actually, we're going to move this window to the side to make it a little bit more clear. And we can read all of it. And that is exactly what the borrow checker is telling us. It says, and this is error 502, cannot borrow self as immutable because it's also borrowed as mutable. Okay, so maybe you think, okay, so, well then why can't we just make this version of bank mutable and then we just borrow self? Well, that's another problem because you cannot borrow self as mutable more than once at a time. And this is the other borrow checker rule, right? It basically means that you can only have one mutable reference to bank at a time. Does this make sense? Actually, it does, right? So if you had multiple people that were unaware of each other, that were depositing, that were doing things with the bank, the problem is that maybe there was an iterate, like a counter in the bank, like for how many deposits have been put and so on, and then multiple functions could change this without it. Okay, actually, let's have another example. If you had multiple mutable copies of the bank, then one of those functions that were working on those mutable copies could simply delete the bank. It could clear that memory, and then you would have a dangling pointer. You would have nothing there for the next pointer that used it. So, or the next method that used it. So this is like that core principle that as long as you are editing something, only one function can do that at a time. Or you can only have one mutable pointer to some data at the same time. Okay, so this is the reason why this failed. So then what are the answers? How could you potentially solve this? Well, the simplest way to solve it, I guess, is simply to do your calculations here from the deposit. So right now we're gonna do this thing. We're gonna simply run this, and this should run. Yeah, fine. Okay, so let's print the balance, and we have created 100 bank accounts with ID 0 to 100. So we can say account, and then we'll take the ID. ID equals 42. So let ID 42. We give it the ID. Copy types. We don't have to worry about anything. Bank account number. And then we say account NOx, which is Norwegian kroner. And we do it like this. So it would be the ID and and then actually, yeah, so how will we know? Well, we would need to, actually what we can do is we can have this function return new balance. We can get the new balance back. So right now it doesn't say what that is, but we will simply have this return an I32, and then we will, can we just do that? No, we can't. Okay, so then we will say that the last thing we want to do is we will return the account balance. I32, right? And yeah, okay, run this print line, and the macro is like that. That's right. There you go. We have deposited money. We can deposit a little bit more. We can deposit, let's say, $400 as well. Then we can also, that's okay. We don't need to do anything more. So we have now made a system to deposit money into the account. So now that worked, but of course we wanted like to have some score. So what we'll do is we'll try to, what we would do here is we would implement a logic here that would loop. For instance, we want to know the mean score of all those, of all the bank accounts. So what we would do now is we would implement it here. We would implement it inside bank. So bank now has the logic for holding the calculating the score. This adds maybe some complexity in the sense that, let's say that there were several different bank accounts. How does and then maybe those accounts had different ways of calculating the score. And then how would you do that here? Well, the bank would have to know all these methods, so you would not be able to modularize it in that sense. That would be more of a problem. The other thing, okay, we can actually have a look in the Reddit post, not the Stack Overflow post, that was an answer to this. So there was a user here called Shepmaster that actually call out my post as a duplicate, and it is hard to. It's really hard, in my opinion, to know how to word these things. So these are answers that produce for the same question, but I think that one of the more interesting questions that they had here, and where I found the most interesting answers, was in the situation that you have a game where you have a field, and that field has a ball, and then the ball needs to, when the ball calculates its position, it needs to know the position of the walls of the arena where it's being played, and it needs to know the location of the other balls. So, so then it would seem natural that you would pass the field into the update function for the ball. And in many ways, that is exactly the same thing that we are doing right here, or that we are trying to do. The update function needs to know something about its owner, and then you have to pass these references, and Rust doesn't allow us to do that. So there were several answers to this question. So we will, I think the first answer is simply moving the logic out into field. So when you call update on field, it tries to call update on ball and tries to pass field to the ball. So it has to pass information to the ball for that update function. So again, like we did with the bank, we could simply move the logic out into the bank. So in that case, it would mean that they would move the logic out into the field for the updating positions. But there are other solutions. You could pass in the case of the bank account, you could pass the information you needed into the update function. So we can try to do that in a moment. We can try to pass all the other bank accounts into the update function. Actually, let's go through these solutions one by one. So we will try to do that. What we're doing now is that in this particular case, we want to use the deposit function. And in fact, look at this. We can now, if we don't need access to the bank, we can do account.deposit. We can deposit the amount. And now, effectively, we should be getting this to run. Yeah, so that is no problem. So how do we... Yeah, so now, okay, so now this is an interesting thing, right? Because now we are... Let's try and see if we can get this to work. Because one of the questions here is that we are now getting a mutable copy of this account out of accounts. So what we would have to do is we would have to pass all the other copies, all the other accounts into account. Can we do that? Okay, so let's try and see what we would do. we would ask, we don't need that to be mutable. So we could have a vector of account. So it would be accounts. And that would be a vector of accounts like this. So in this case, what we would think that we could do is that we could simply pass self accounts. And we would not move it, we would pass a reference like this. Does that work? Because we cannot borrow self accounts as immutable because it's also borrowed as mutable. That means that right now, probably because we are in self, we cannot do that in this particular case. We could imagine that we now extracted the amount of money from all the other accounts. And perhaps we could then send that, pass that in. But okay, so but we are equally far here. And in some ways it makes sense because this requires that you have multiple mutable copies of the accounts, even though this is unmutable. We can try just to check that this is actually the case. We can do unmute, but this would probably induce a multiple mutable borrow, right? Yeah, we cannot borrow it as mutable more than once. Okay, so this solution does not work for us. Let's say that the score would rely on knowing all the amounts of money in the other accounts. Well, then we could extract that amount into a new vector and then pass that along. That we could probably do. So in this case, we do account balances. And what would that be? Well, it would simply be a vector of I32s. So we can create that vector. We can try that now. And when we are doing that, we will also try to create. We'll use this collect function. I think this could be an interesting experience. So we will say amounts or account balances, and the account balances would take self accounts, and then it would take. I think okay. So the way this is done, I think, is you can now. So now what you want to do is you want to extract one member of each. Is that map that we're going to do? We're going to take accounts, and we're going to take. Just going to try this. We're going to make an iterator, and then we will map that iterator. We'll pass it an enclosure, and the balance will be. A will be an account, and then we have an enclosure, and that enclosure returns a.balance. So that is a copy type. So, okay, so this construction here, as far as I understand, we can have a look at what it does. Yeah, so this gives us an iterator, and then this we will collect this. I think this is how it works. Yeah, so actually what happens here, if I understand correctly, is that this takes the vector and creates an iterator. It gives the iterator. Iterators have the map function, and the map function takes the iterator and creates a new iterator. This is also how you filter and fold in Rust. So this is more like functional ways to approach it. And then if you want the data and not the iterator, you take collect. Now we can actually have a look and see what does it. I'm a little bit concerned that it doesn't tell me what type this is. It might actually be that we have to tell it. So what we are looking for is a vector of I32. Well, it does compile, and or it does not. It might not compile, but it tells us at least that that's okay. And then we are going to borrow it, this vector. Actually, we don't need to borrow it. We can move this vector in, because we're only going to use it once. Okay, that didn't work. Of course, it didn't. Okay, so where is our problem now? Okay, so yeah, okay. Okay, so we cannot get the iterator. So in order to create the iterator, you have to pass self accounts probably into a method, and there you are. And the problem now is that self account is mutable as it is right now. Okay, we're stuck again. Let's try an alternative. Is there any way that we can, isn't there no way we can do this? Okay, so this probably means that all these properties of self, when that's mutable, are also mutable. That's the problem. This function, what does this take? It takes, yeah, so it takes an immutable copy of self. But okay, so do we have to? Is the problem here that this goes into the? Maybe this is the problem here, that it goes sort of into it here. Okay, so that did not work. That is interesting, because then does that limit how you can use these iterators in functions? Okay, let's instead we'll loop for it. So we'll do for account in self account. So this should work. So we're now going to create, instead we're then going to create a mutable vector called count balances. Interesting, because now it just guessed what that was here based on its usage down here. I'm just going to create a vector from that, which is like this. And then we're going to take the account balances, and for each account we're going to push. Yeah, oh yeah, of course. Wrong character here. So for each of these, we're going to push onto the account balance a copy, then in this case, of the account.balance. Will this compile? No, cannot move out of self account. So what is that? Is that what's happening here? Okay, so we cannot use the iterator down here, and we cannot use the iterator here. Can we borrow it here? No, not what we want. Okay, so we cannot actually iterate over. Can we do, if we didn't do this, would we be able to iterate over the collection? So we're actually not. Okay, so we're not able to iterate over accounts because this is a mutable copy of self. That is strange. Okay, so let's have a look at that. I think this is something to Google actually. So we're gonna search for iterate. This is probably a Stack Overflow question. Stack Rust iterate over on collection mutable self. Yeah, so they are trying to get an iterator for these items inside. Maybe this is not what we're looking for. As mute. Okay, so Chessitup is saying that as mute. Okay, so thank you for that, by the way. You mean that I should put I should put this or the accounts as mutable. Is that what you mean? Cannot infer types. Okay. Will it be here then for account, which is a vector of account? No. No, so I cannot do that. Okay, so again, our problem is simply that we are, this is the worst learning curve for me at least. So we are depositing money into an account that we own, and then the question is, we're trying to get some information about the other accounts. Is the problem here that I have this? I wonder if I didn't have already picked out the account. Will it then work? What is this? Why is it a problem? So I'm wondering if it is this picking up with the, okay, I see, maybe that's the problem that I'm doing here. Let's see. Let's start this one over again. The first thing we want to know in this particular test is we want to test we want to have a list of how much money is in the other accounts. So the initial idea here should be pretty simple, right? You want an account in self.accounts. Yeah, in this case, we can just actually, this is of course now complaining because we're returning number. We're just going to return 0 for now. Okay, so the question is, does this run? Okay, so no, that does not run. So inside this mutable self, I cannot do this. Does that mean that so as mutable, I cannot call that on account. So because of the mutable self in this deposit, I seem unable to mute through these or to iterate through these accounts. Okay, for each loops aren't a thing. Try using length index or using an iterator. Okay, so that's the problem. Is that the problem here? That it's that I need to go over the length. Okay, we can do that. Okay, right. So the problem with this construction right here is that somehow the iterator needs a copy of the accounts, and that doesn't work here. But we can, of course, we can do a for loop. So we can do for iterator in 0 to self.accounts.length. I am going to assume that we can get that one out. And then we can see if we can run this loop. Yeah, so that runs. Okay. So the problem in this case is that we couldn't get the iterator like that. Okay, so thank you very much for the input there, Chasitup. I really appreciate that. This is one of those things that really, like, you have to have new patterns when you learn this language, it seems. And this particular thing, this was really hard for me to catch. But of course, it makes sense in the way that you could do this. But it also seems slightly inconvenient, right? Does that mean that if I had a function that was non-mutable? Yeah, how are you liking the language, Chasitup? And I'm also curious, like, do you have any specific plans for how to use it? Because like I'm getting into this because I'm curious about making some WebAssembly code and some cross-platform code. So I'm very, very curious to hear what other people are thinking of using the language for. And I do agree that it's good. It's just you need to add some new patterns to your mind. I'm going to try to. I'm just going to try to do this. I'm going to do a non-mutable function here, and then I'm going to try and see if the for loop works inside this one. So it still compiles, and then we would do simply here, we would do test, or we would do bank.non-mutable. Run that, let's see. Yeah, so this we're allowed to, of course. We are now passing non-mutable, and then I'm just going to see if our iterator and stuff works inside here. So let's do self. So basically for account in self accounts, does it work inside here now? No. Right. Cannot move out of self account. Yeah. So it is the case. The thing that surprised me here is that I'm of course thinking that I would like to do things like self accounts, and then I would like to filter this, for instance, or I would like to ask for an iterator. Oops. I would like to ask for that iterator. This is how I would think in other languages, and then I would like to do filter, right? A filter map, and then I would pass something in here. So let's say that I would only want, I would return the account like balance over. So I would like to have all the accounts over this sum. Yeah, so I can't infer type. This would of course be a params equals, and it would be a vector of accounts as well equals. It would be like this. Oh. Can we build from iterator account? Oh yeah, right. Okay, so we are. Yeah, of course. Now we are creating, of course, because it did allow me to do that. This means that we're now filling up lots of immutable vectors in this one. So that did work. But it didn't work here. So ChatGPT wants to work with Actix web faucet framework in existence. Yeah, I can imagine that if you write code with Rust, you're going to get incredible speeds. So the reason I was looking into it again is because of WebAssembly, and I was looking into Go, which is easier to pick up, but the WebAssembly assemblies are huge. So the idea that you don't have to bundle like garbage collector and stuff like that with these WebAssemblies makes this incredibly attractive. But it's not great. Yeah, at least it makes you reproduce a lot of code, right? That was the thing that got to me. Yeah, I can see that. So I prototyped something in Go for this particular project to try and learn it. And the thing that struck me was that I was rewriting everything and not having generics. Really, really grind me. Yeah. But I heard someone say about Go, though, that where I've seen it written, that the fact that it's so sort of verbose makes it easier for people to understand, like other people's code. But I don't know. It's really, really hard for me to know. But the size of the assemblies that are generated is a deal breaker for the project I'm trying to do this. Yeah, and the Rust compiler messages are very helpful. But what I do find is that you have to really know the concepts of Rust before those messages. The messages are certainly not a tutorial, but that is more than fine. Okay, so we have figured out how we can iterate over this. So in this particular case, we have now, in this case, we would be able to collect our accounts, and then we would pass these amounts into a deposit function, the balances. We can, I don't think I'm going to finish this example, but that's what we would do. We create a new vector of I32s with the balances from these accounts. And then we would be able to do this scoring in the account as we use this function. So the other example from Stack Overflow was okay. So the other thing that was suggested here by the user that we could do as an alternative way to implement this, again in the ball and field example. So so you could pass the data that you needed into it. You could also wrap the data that you needed to pass into the function into a bundle, like in this case a ball update info. So it would mean in our case that we would create a structure with the information we needed to pass to the account to calculate the score for that deposit when it was happening. I don't think I'm going to implement that one. And then there was another version here in which it's a similar thing, really, where the field contains information about the current update, and then you would pass that into the function. And then they also have some so this last example is actually quite interesting, and I saw this this in the linked list example, which is a book that people read that helps you understand the memory management of Rust, which is it tries to implement linked lists in all kinds of ways. And I think everyone stumbles upon this book eventually. And that is this thing that what we could do in some cases is that we could take the vector of accounts out of the bank, and we can replace it with something like a nothing. Or if the accounts were wrapped in an option, then we would replace it with none using the take method. But the idea here is that you take it out of the bank, and then you can do whatever you want with it, and then you can pass that into the function, and then you would put it back once you were done with it. At least this is how I understand this particular example. And the other thing is, and I thought it was well done the way he put it here, is that sometimes when these things are difficult, you can, with the typical type system or with the borrow checker, you would take these APIs that Rust provides, like in this case refcell, where you defer the problem of the checking of whether it's accessed more than once to runtime, and your application panics at the point where you use it the wrong way. So that's how I understand this refcell. If you need to have an object that has that you need to be able to access multiple places, you can wrap it in a ref cell, and then you can borrow it as mutable from that cell. And if this happens more than once at runtime, your program will panic. Okay, so there was one more example that came out of the Discord, and that was that you would, instead of putting the logic inside the bank, you could simply namespace the update code inside the count. So you would have an update function, which would be something like deposit, but it would not have a self. You would pass something else into it, but of course that doesn't really solve our problem. Deposit 2. So in this case, you would be able to access this without accessing the account object. So you would do account, then you would do deposit 2. So this is like, it's like a static static function, I guess. It doesn't have a self object. But these things amount to much of the same thing, and it shows sort of you have to rewrite in these cases the code to fit this borrow checker paradigm. And that, I think we'll get back to our epidemiological model, and we will try to do it here so that we can have complete the actual task that we are trying to do. I don't actually, so Chestitup is saying in the chat, we were discussing Go earlier, and said that the Go compiler messages aren't that great. I can't remember, but I do remember the compiler was very fast. I think when they introduced it, at least they were recommending that. Yeah, and the nil pointer does exist, yeah. So I can really see why people that do this kind of programming would appreciate Rust, and why it's sort of worth the learning curve. But it certainly is a learning curve to this language. Okay. I'm just gonna have myself a glass of water, and then I will be back, and then we will continue the development of this simple epidemiological model, and we will also modularize it a little bit so that not everything is in this monolithic file, and then we can also look at it a little bit side by side. So let's see. I had myself a little slide here. So we looked at the copy types and move, and why that was surprising me the last time. Let's do this. And then we looked in this passing mutable self-reference to method of own object. We looked at that. And then the next thing up is continuing the development of our little simple epidemiological model, and then I will be, hopefully we'll manage to get a little bit further today. We'll think a little bit about which approach to take here for this, because again, I want to make this multi-threaded. Part of the idea here is that I want this model to be really, really fast, but then again, I also want to get it running before maybe I start optimizing it for multi-threading. So yeah. Okay, so I will be back in just a moment, and then we will continue the show, or whatever you want to call it. Okay. There we go. Okay, so I'm back. So hello everyone, and if anyone new has been joining in the break, this is broadcasting my complete failures in the learning curve of Rust, and trying to battle this borrow checker, and trying to get my head around alternate patterns to solve programming things that I've been solving for years, and now trying to figure out how to do them in Rust, given the limitations that Rust has. So the goal of this stream is to develop a simple epidemiological model that will look a little bit about the characteristics, very, very simple. But it will illustrate the characteristics of how epidemics develop. And I think this right now, in this point in time, everyone knows what will come out of this model because of the situation around the world. But it's interesting that how these simple models can illustrate the things that we are seeing and sort of simulate those things. Okay, so the original problem that we had, the thing that derailed the end of the last stream, was this concept that you have that the simulation, that the person, okay, so a simulation consists of a vector of people that are being simulated, and they need to infect each other. And I placed the infect method on the person object. And when we are running the simulation, the problem is that we cannot call the infect function from the simulation because that means that, or the infect function needs to know a little bit about the simulation because it has to be able to pick some people that that person will infect. And the problem here is the flow of information in this case, because that means that the infect function needs to know a little something about the simulation, and we cannot pass the simulation itself into the infect function on person because the person is contained in the simulation, and from the method on simulation you'll have simulation as a mutable reference. You cannot pass the reference into person. So we looked at the option that what we either now need to do is we need to put this logic of how people are infected out into the simulation. That is the simplest solution. But we also have the thing that it might be that you want to add. So if you want to take this a little bit, that will be a very simple answer. But if you want to take this model a little bit further down the road, you can imagine that there are different types of people in your model. One, it might be that people respond differently. You want to populate your simulation with different kinds of people. So one idea has been that maybe we want to have person to be a trait, and that we want multiple different structs or objects to exist that implement person differently. And that means that the infect function will be implemented differently between different kinds of people. But I think for the sake of this example, we will simplify this greatly, and just to get this model on the road, we will swallow this pill, and we'll take the infect logic out of the person and put that into the simulation. That means that that current person is just an information carrier. It has no method, so we're not really thinking about this in an object-oriented manner, I guess. Let's see. So now what we have done so far in this case is that we are trying to populate our okay, so let's see where it crashed last time, or where it didn't compile last time. So we are creating the simulation, and I think that works. And then the problem, I think, arose in compiling. Did it arise here? No, because we did generate these. It might actually be that I removed the code that was causing us some trouble. Let's see if let's just walk through this very, very simply. We create a new simulation. 10 times we pick a random person in the simulation and get their ID. Then we pick this person out of the simulation. So we get mutable on the people vector, and we unwrap that because we don't care about errors in this very simple experiment. Then we call person infect. And in this case, this function no longer exists. So right now we need to call, actually, in this case, we can just simply tell the new infects function simply needs to tell the simulation to infect it. So what we'll do is we will do sim.infect. We'll take the ID of the person to infect, like that. And then we no longer need to get the person out of the vector. But just for debugging purposes, we will print the ID of the person we infected. Now the simulation infects this individual, and that, let's see. So So right now it gets a mutable version of itself, and we need that because we need to mutate the individual. So we need to get the individual, so we'll get person. Let's see. Person equals, we'll do self, we'll get people, and we'll get mutable. And the index will be, it's the only parameter. It is in the IDX for index, and it's a usize, or actually we have one called, we call it ID. It's prettier if we continue it like this. If we just use ID. It might also be in the future we don't want to have the index. Maybe the ID will be accessed some way differently. Maybe we'll put a hash map in there or a map of some kind. Okay, so we'll get the mutable with the ID, then we will unwrap that because we don't expect errors, no, do we? If there's anything we expect in this project, it is errors. This is a stream about errors. However entertaining that may be. Okay, so now we have the person. Okay, so get the person. Then we will create a course, like a clinical course for this person, for the development of the disease in that person. So we will, and we've also simplified this greatly. There is no like incubation time or anything. We simply say that we will infect 3 people. And this is again for simplification and to get to the end as quickly as possible of this. Each individual will have exactly the same course. Although, because in this particular simplification, this simple version, we don't gain anything, I think, from adding random variance or stochasticity to this problem. So since we're just trying to learn the language, we'll avoid that and keep it as simple as possible. So create clinical development of disease or infection. So in this case, the course is a vector of sick days. We create that, and then we want to infect 3 people. So 3 times we pick a random individual from the simulation, the same way that this person was picked. And then we append to the course this new vector, which contains 3 sick days where nothing happens, and then finally it infects the individual that we picked out here on the last day. Okay, I do hope this works now. Yeah. And then we set the course on the individual, and at the point where we have infected the person, the state of the individual is infected, and the person will remain in this state. And what we'll do as we will tick the days forward in the simulation is we'll slice one sick day off on every iteration for everyone that's infected, as long as there is something in the course. Finally, actually here we will add the final state of the individual as being alive or dead, as the final result. Or no, actually we can do that in the update function. We'll get back to that. Okay, does this compile? No, let's see. Not found in this scope. Sim pick around my DX. Let's see what our problems are. Cannot find value sim in this scope. So we are here. Of course, because it's self. We moved it out. No field course on type and with simulation. Yes, of course, because it is the person that we are mutating. Yeah. Okay, more problems. Every time I get a little bit, every time I see this, but that's okay. It's worth it, right? Cannot borrow self as mutable more than once at a time. Yeah, so we have the same, oh yeah, of course, we have the same problem now, do we? We're calling a function on ourself. Of course. Because we have a mutable reference to self in infect. Because here's actually a question. Yeah, so no matter what happens here, we cannot call another function on self. Oh, can we really not do that? So if this was unmutable or unmuted, So in this case, in this particular case, then there's a pick random. Why is pick random muted, by the way? It should not be that, because it doesn't need to be that. Let's have a look again. I don't think it's going to compile after this. It is the same problem. The problem here is that we need to we gotta pick a random person from ourselves, but we cannot call this function because we already have a mutable reference to self, but we cannot do it again. Does that mean that if you have a method on an object, you cannot, or maybe I'm thinking about it the wrong way. I'm thinking about these as objects, but that's not what they are. I have to think about these as structs that have methods on them. But you if you call a mutable method on one of these structs, then that cannot call another function that takes a mutable self. I guess perhaps that is simply true, and then you really do need to think differently about this. But let's do that. So there's no reason we need to really pass. Well, there is a good reason we need to pass this in, because in order to pick this random number in the simulation, we need to know the simulation. We cannot replicate this code in every function that needs to pick a random number out of the simulation. That doesn't work. Is the problem that this relies on self rather than some information about? Because let's say that this information existed as another struct. I'm going to try an experiment here. I'm going to create a struct with simulation information or sim struct sim info, and that will contain the sim information will contain the number of people. That is an I32. So the simulation will then have one. Yeah, of course. Maybe the problem sort of becomes the same. So we're going to have an info, which will be a sim info object, and then of course now when we create the simulation, we need to create one of those. So the sim info will then simply contain n people equals n. Yeah. So now we've. Oh, that's u size, but that's okay. It's a u size. Because now we have this this info object on the simulation, or this info structure. But the problem here, I guess, is that we can't just pick that out, can we? Or can we? So let's say that now, instead the pick random thing, let's say that can we take let's say that we didn't do this now. This should now compile, right? Yeah, so it compiles and it does generate the sim and it does that. So let's can we take the info out of the sim? Like you can do info equals self info. Cannot move, yeah. That makes sense. So I guess we can't borrow it either, can we? Yeah, so we can borrow it. We're borrowing it from ourselves. So let's now say that pick random is a simulation pick random, and it takes the info object. Can we just have? There's no shortcut to generate this now. Let's try this. So we're now going to create a public function called, actually we're going to remove the self here, and we're going to do a mutable and sim info, so it will be info. So what we're doing is that we're replacing this length of the people list with the info dot and number of people. So now the pick random it works like this. Of course, it's gonna I started the function here that I didn't complete. And of course, we are already calling pick random somewhere else here. We're calling it when, yeah, here we go. So we would also do here simulation. We would do pick random idx, and we would use the sim.info, and we would borrow it back. And it compiles. Okay, that is quite interesting, because it means that, okay, so what does that mean? Because this is not a copy trait, so we are actually borrowing it here. We're not copying it. We could copy it. We could add the derived from the copy or copy and clone trait here, and that would work. So okay, so we are copying. We're not copying. We're actually borrowing it. But now it does compile, right? It makes you actually wonder if this. It makes you wonder if this. The one thing it does make me wonder about is, what if we move the people array into the info? Like, think of it as a simulation state. So the info was now sim state, and it would, and the info, so what you're sort of doing is you're passing the state, you're borrowing the state into the functions that you need to do. But we have the same problem, perhaps. I think we're going to look into that later, but I think right now the more interesting thing is to get the simulation to work, because now this should work. We can actually pull the simulation out of the let's just we could create the update function now, and we could actually have this run, which would be sort of satisfying, although it's perhaps not setting us up very easily for the future by ignoring the problem now. But let's have a look, just to have a look at what the person object looks like here. So yeah, so of course that I'm no longer getting that. Let's jump into the infect function, and I just want to inspect one of these individuals before we. Okay, so now we have. No, that I didn't there. Just to continue. Did I put it on the wrong place? So after, yeah, of course, it doesn't actually allow me to do on the exit of functions. Okay, so in the end of state, we now have a person, and this person has an ID, and it has a state. It is susceptible because we haven't updated it here. And this one, we will set it to infected. So this individual 2008-57, is susceptible to the disease, but in the next step here, it will be infected, and it has a sick course, which is 11 days or 12 days. And every third of these sick days should infect someone else. Yes, so here it infects, and it infects this particular user. Then 3 days later, the individual also infects this particular user, and finally on the final day, the person infects this user. But on the other days, he infects nobody. Okay, so we know now that that's correct, and we can actually now principally run the simulation. Which is sort of interesting, right? So I think we're just going to go straight to that, and then we'll look into whether we should think of it as a simulation that has a mutable state that we can encapsulate the state in another object, and all the methods on simulation pass that object around. Maybe that's another way to think about this, or borrow from the simulation either as mutable or immutable the state, and maybe maybe that is actually a better way to think about the simulation, right? It's interesting. It forces you to think a little bit, but the question is if that would work. But it certainly now works with this info object that we did here, right? That is one of the solutions that was suggested on Stack Overflow. Okay, I also wanted to tidy this up a little bit, but let's just write the... I hate these huge monolithic files. I like to modularize as much as possible, as long as it doesn't like become over-engineering. But let's do the next day function, because it is cool that we can now get to the point where we can have this run, right? So, okay, so what we'll do, we'll add a loop to main that will go through for n number of days. So we'll do day equals 0, no in 0 to, we should make this configurable, but for now we'll just say that we'll run the simulation for 300 days. Actually, let's run it for just 50, because otherwise the list of, we want to dump some stuff along the way to see how it goes. So we'll just loop for 50 days. And for each of these 50 days, we will do sim next day. I don't think we need to pass anything into this, because this simulation doesn't really have to know what day it is. The simulation just reacts to the previous state. Okay, so what will the simulation do on the next day? So the idea here is that we will find... Okay, here we go. Yeah, so now we have one of those problems again. We need to find all the infected people. And then we need to have mutable references for those people. And then for each infected individual, we need to take the first element in their sick day, in the first sick day in their clinical course, and then we will look at what that is. If it doesn't infect anyone that day, we just pop that out, or we just slice that out of the vector, we remove the first element. If the first element says that we infect someone, then we will call the infect function on that individual. And this is the way the simulation works. Also, actually, what we need to do is we need to... Yeah, I actually forgot about this. When you infect a person, there are two potential courses, right? Either the person is susceptible or the person is not. If the person is already infected, then nothing happens. So we need to check the person's state here. So we're going to say, we're going to actually say match person.state. Now we're in the infect function. And as far as I understand, we can now, I think Sea Lion provides us with fill match arms. Yeah, here we go. So actually the only state that we are interested in here is susceptible. If it is, so I think actually we can't we put logic here as well? So let's have a look in the statements, the match things. So I think we can actually create a logical expression here. Rust match expressions. We wouldn't say that any state that is not susceptible we return. We don't do anything. That was a weird search. Rust match expressions. So yeah, maybe this is not what we're looking for. Yeah, maybe. Okay, so can we say not susceptible? Match arm expected. No, so we cannot do that. So we can susceptible, and then we can, it's like we can say the default thing, right? So if it's susceptible, then I think the default is written like this, I think. So it stays susceptible, and for everything else we return. The builds. There's a lot of warnings here, and that's because I've filled this up with things, but we will get rid of those eventually. Okay, so I have roughly 20 minutes left of this stream before I have to go do other things, so I'll definitely try to get this running now. I'll prioritize getting some data out of this and getting that beautiful sigmoid curve that shows how epidemics develop. Okay, so now we know that if the person is susceptible, we go on, but if the person is anything except susceptible, we return. So that means that the infection no longer has power over the individual. If the person is sick, nothing happens. If the person has recovered, then nothing happens. And we're not really, yeah, okay. So let's keep going. So what we need to do for the next day function is that we will take, yeah, so we need to find all the people that are susceptible. Can we do that? We had some trouble looping, didn't we? So could we not do for This is the for loops that our friend in the chat warned us against, for each loops earlier. So warned us against that we had to use a for with length. So that means that probably the for each loop will still not work here. I don't see why it would for insult people. Will this compile? Because then we have to pass it into the iterator. No. So in order to do this, we have to pass people, or we have to get an iterator from people. We cannot do that in this state. So we will do a for loop again, where we just loop over the indexes. So what we'll do is we will find the individuals. Yeah, so we cannot move them out of the array, but we can find the individuals and get mutable references to them, so that we can see what to do with them. So we'll do for the iterator in 0 to self people length. This is a very nice syntax. I really like how this is a for each loop. It's a for each loop for this range construct here. Neat. Okay, so we will be allowed to do this, right? Yes, we are. Because we're not actually doing any methods on the people thing here. Yeah. Then again, the question would be, if now people were contained in an object, the simulation in for the simulation state, and then we took that state out, then maybe we wouldn't have this problem, and we could actually use the for each loop. A way to test that is actually create in the, we can just check this now, in sim info, we're going to create a vector of people. It will be empty. This is just for experimentation. So we'll create a vector of person. And then we have to fill in the field here. Some beautiful C line tricks here, add missing fields. People, and we're just gonna, so we're just gonna do vec. This is an empty vector. All right, compiles. So now the question becomes, okay, let's get the in next day, let's get this sim info out. Let's call it state, and then we take self dot info, and we're gonna borrow it. But it has to be mutable, right? Yeah, because it has to be mutable. Okay, let's see it first if this compiles. Can I do this? I can do that. Okay, so that actually does mean that if we now wanted to have, this is okay. Now I think this is a very strong argument. If this way of looping works, that I think will work now, then I think we will actually move the people into the state object. So if you now took state, and then that has a people object, right? Then we can get an iterator. We can filter the iterator using an expression, and the expression will take the person and, oh, it's a double. Okay, oh, that's nasty. The type here is weird. Okay, does that work though? Let's see. So can we now get p dot? Yeah, we can get. So we'll filter by saying is the state and what's called condition. Now it's called state. So now the thing here is that we are only interested in the people that are infected in our simulation. So I'm trying to filter out those people, and let's see if we can we collect. No, we don't need to collect it, because now we have constructed ourselves a disgusting iterator. So he'll say, so each infected. So for infected in, does this work? Oh, this is such a disgusting expression. No, binary operator cannot be applied to type state. That is interesting. So I cannot compare enums. Can I not check if this is the right type? Okay. So can I compare? Let's do. That is also interesting. Rest compare enums. How to compare enum without pattern matching? Yeah, that's what I want. Okay, so we have to derive. Can we then do it? If it is that simple, then that is something interesting. So we say, can we just do, and it compiles. It's interesting though that we had to do that was not like the default thing that was included. Okay, but we made ourselves one disgusting iterator or one disgusting expression here, but we can put it out here to make it better. So we can call it infected iter equals. Are we making it simpler? Maybe not. We can take this closure and we can say is infected. Can we? And then we can put the maybe that didn't help. So P is infected P. Maybe that was not very helpful, was it? No, we really just, well, we replaced just the inner part of the closure. Okay, it's not worth it, maybe. Let's go back to having that directly inside. Of course, this will look a bit cleaner when it's out of C-line because these type hints will not be there. Okay, but this is now we're getting somewhere. If this compiles, yeah, it does, right? It means that now we can loop very specifically between. We can loop through. Okay, actually, let's do it like this. We'll take this expression out, and we will say infected iterator. Yeah, it's this, and then we will do it like this, and yeah, so we will get a borrowed person reference here. But of course, we probably want to borrow these people as yeah. So the trouble now is that we need to borrow these people as mutated, right? Can we just do mutate here? Now we can mutate that one, but not the people coming out of it. So maybe. And I'm pretty sure we cannot borrow these as mutated here. Can we? Is there like a? Is it like a? Yes, we do have a mutatable iter. Okay, and that also compiles. Interesting. So this probably does mean that we can now take infected. So we can now get all these infected people, and then we can change their state. So this person, for instance, we will be able to take the course. So let base equals course, and we want to borrow that mutable. So do I have to specify? Yeah, so it's already mute like that. Okay, so that didn't work. Cannot move. Yeah. Oh yeah, so it will borrow. Yeah, can we do this? Probably not, right? It does allow me to do that. But it looks weird, right? Okay, so what we want to do is we want to, for that person, we get this. Actually, we don't need to do this. What we want to do is we want to pop the first one off. So we need to take the first. We need to take the first item from this element. So we need to use this vector as a Q. But that's certainly not pop, right? What will we use? Let's also fire up our browser for this. Let me say, let's say do rest vector take first element. Do I get I want to. I think I looked this up and it was like replace or splice, right? So we'll do rest vec splice or split maybe. Not a slice, that's definitely not what we are looking for. Can we do split? Rest vec split. Then we can split it on the first, right? Or remove. Yeah, so okay. So removes and returns the element at position index. Okay, that's what we want. So of course, and then we want to remove 0. What does this come back as? This actually, okay, so it does return an option. Does it do try remove? Do we have that? Try remove? No. Remove item. Okay, wait. Unstable, recently added. Removes the first instance of item. Okay, that's not what we want. We want to have remove, but we do need to have a check here that checks whether there are any items left. Actually, we don't, because we'll never get in a situation where there are no items left. So what we'll do now is once we so let sick day equals. Now we have the first sick day in the index, and what we'll do now is we'll say, okay, so if after we let's try and see if this works. This will of course panic if there was no sick days. So let's do. So now what we want to do is we want to say we need to check if the course is now empty. That's the person has finished its course. So for now we will not kill anyone. We will not we will not say that anyone dies of this condition, but we will say simply that the if course if infected dot course dot length is 0, then this person state equals, and it will be condition, no, we call it state. The person is now recovered. And that means that we're not taking them out of the pool of people that can be infected. People can call the infect function on that individual, but the person is not susceptible. The person is recovered. So the next thing we want to do is we want to take care of what happens if the sick day, so we'll match the sick day. We'll match the sick day, and we will do an exhaustive match here. Yeah, so it will infect P. Okay, so if there is nothing on the sick day, then we don't do anything. But if the person infects another individual, then we now need to infect that individual. So okay, so here's the so we implemented simulation and we implemented infect. And P now contains the ID of that individual. Yeah, so okay. Yeah, so we need to get that individual. That's what we need to do. So we need to let person equals self dot people dot get and we need that person to be mutatable, and we will get that at index p, that's what it is. So then we now have a person, and we will infect, don't we? Yeah, we have an option. We will assume that we get all of them, since we're not actually changing this vector. So we'll do unwrap, we're not doing error checking, and then we'll do person, and then we will infect that person. No, that was actually, wasn't that the simulation? How do we? I thought we had written this so that we didn't have to call. Okay, so if that was the case, then because now we are, of course, inside the simulation. So we want, let's see, self dot, because that's not going to go, is it? Because it's a reference to self. In fact, and then we want to infect p, but that's the problem here again is that we have a method on the simulation, and we are calling. We have self, so we cannot do that. We cannot pass that along. We're borrowing a self as mutable more than once. So we end up in that same pattern. It seems like when I try to think about these things in an object-oriented manner, we get into trouble. And that is okay, but what I think is the answer here is actually that we would have to take the, again, the problem here is that we need to pass the simulation, but we see if we take the simulation state out of the simulation, like we did up here, we could pass the state into an infect function, and then it would work. But it raises a lot of questions, so I'm actually out of time, so I will be unable to finish this simulation today, which is okay. I always thought this would be a multi-day stream. But it raises interesting questions about how you design your code, because if you cannot from a mutable method on a struct call another mutable method on the same struct, then you definitely need to think differently about how you organize your memory. So it's an interesting challenge there, because it means you cannot think in an object-oriented way when you're mutating your objects. Maybe because they aren't objects. So maybe at least that's how I would think about it at this point in my learning curve. And maybe this is the wrong way to think about it. It might simply be the wrong way to go about it. But we keep getting into this particular issue, that thinking about the objects as having encapsulated behavior seems to be difficult if they are read and write rather than just read. So I need to think a little bit about this one. And yeah, I think I'll end my stream there, because I am out of time for the evening. But it's an interesting, it's a bit fascinating to be challenged on these architectural decisions. It's also fascinating that just simply putting the simulation state in an object inside simulation and taking that one out and mutating that one seems to solve the problem. So yeah, I need to think a little bit about this. Okay, but I think that's it for today. So thank you for anyone that has watched, and thank you very, very much for the interaction in the chat earlier as well. It's always cool to hear from people during these streams, and also to hear what people want to use the language for. And it was interesting to hear about this web framework, Actix Web, and that it's fast. I do think my hope is that Rust, if you properly learn Rust, you'll be so efficient in it eventually, and you'll be able to anticipate how to do your architectures, that you will sort of you will not get into trouble, and because of that you'll still be able to do really fast and applications and even prototyping things in Rust, because you will be good at the language, and then you have an enormous speed increase, it seems. You have efficiency, and you can run it in things like microcontrollers and stuff like that too, which is neat. It's actually something that could be interesting for the place that I work. Okay, but thank you again for anyone watching, and that's it from me tonight. I'll be back with another stream this weekend, I believe, to try and get to the end of this simulation. All these streams get uploaded to YouTube on my channel by the same name, so if anyone wants to watch this later, then they are available there. And if you are watching this on YouTube, please feel free to leave comments in the chat about anything that you're wondering about, or any feedbacks on my silly learning curve here. Okay, have a good night. Bye.